Hello, I presented the work development of highly porous tantalum and silver composites by powder metallurgy for bone implant application at the 33 International Material Research Congress. This work aimed to develop new composites based on tantalum and reinforcing with silver for biomedical applications. In order to reach our goal, we mix particles of tantalum and silver by adding different quantities of silver, between 10 and 20 volume percent. In addition to have porous compact, we add pore formers that are bicarbonate ammonium salts with a particle size distribution between 100 and 500 microns. The volume percent of the pore former varied from 30 to 50 volt percent. The characterization of materials was made by scanning electron microscopy and by testing the corrosion behavior and the mechanical resistance by compression test. In order to have the kinetics of the sintering of composite, we took a dilatometry test in where we are observing that the melting point of the silver is the one who creates the densification. As much as we add silver, we have higher densification of the compact, which is main due to the liquid form inside the samples. In the microstructure, we can observe that the silver is distributed randomly inside the samples, and we found that the sample with larger quantities of silver create additional porosity. This is because we have swelling during the melting of the silver. In addition, we have the X-ray diffraction analysis and EDS analysis that confirm that the silver is immiscible with the tantalum by observing that no silver is inside the tantalum particles, and in the X-ray pattern we only detect the peaks that are identifying the tantalum and the silver alone. The corrosion behavior shows that the sample with the highest corrosion resistance is the one we have the lowest quantity of silver. This is because silver is less resistant than the tantalum to the corrosion under enhanced solutions. In the compression, we can observe that the resistance is highly reduced by adding the large pores, which allows to reach the mechanical strength of the real bones when we have 50% of volume of pore formers. The 3D image shows that the pores, silver and tantalum are really well mixed inside the samples. In addition, we simulate the permeability through the real porosity created in the samples, and we obtain the values are good for improved osseointegration. In conclusion, tantalum and silver composite has been successfully fabricated by die pressing of powder mixing and sintering above sintering melting temperature. We can reach mechanical properties for similar to the real bones, and also we have a good behavior under corrosion. We have to analyze the osseointegration and osteointegration of this kind of alloy. Thank you very much.